A very good morning to everybody. Respected principal sir, distinguished resource persons, esteemed faculty members, dear participants. A very warm and cheerful welcome to all of you to the first technical session of day 4. We had a wonderful session yesterday. We have learned so many things. Actually, we are learning so many things during this FDP session. So, today's session will be on applied energy engineering from renewable system to sustainable practices. It is the theme of the event. Every new day of this FDP brings us an opportunity to learn from accomplished professionals who bridge the gap between academic knowledge and industrial practice. Today is no exception. It is my immense pleasure to introduce our esteemed resource person for this morning technical session, Mr. Imon Mallik. Mr. Imon Mallik is currently serving as Senior Manager Electrical at Durgapur Valley Corporation DVC Bokaro Thermal Power Station, where he has been contributing since 2009. During his long and distinguished career, he has been actively involved in the maintenance and operation of high voltage and low voltage electrical systems, distribution, transformers, plant DC systems, switch gears, electrical motors, cranes, lighting system and various auxiliary systems of thermal power plants. His expertise also extends to maintenance planning, procurement, contract management, works supervision, ensuring sustainable unit generation. One of his notable achievements includes the successful installation and commissioning of 285 kilowatt power rooftop solar power project at Bokaro Thermal Power Station. Before joining DVC, Mr. Mallik served the West Bengal Power Development Corporation Limited, where he gained the valuable experience in power plant operation and maintenance. He also served as an assistant professor at Guru Nanak Institute of Technology and as a lecturer of Future Institute of Engineering and Management, where he taught core electrical engineering subjects including circuit analysis, electrical machines, control system. Academically, Mr. Mallik holds an MTech in control system engineering from Bengal Engineering and Science University, Besur, Sirpur, with research focused on power quality improvement. He completed his Bachelor of Engineering in Electrical from Polytechnic Engineering and Management, Kolkata. His professional excellence has been recognized through numerous achievements, including receiving the Best Employee Award from DVC on 2 occasions, 2016 and again in 2024, for his outstanding performance and dedicated service. With nearly 2 decades of rich experience spanning academia and power industry, Mr. Mallik brings a wealth of practical knowledge in electrical, maintenance, renewable energy, integration, power plant reliability, and sustainable engineering practices. Ladies and gentlemen, before we commence today's technical session, it is our privilege to honor our distinguished speaker. May I now request our respected principal, sir, Dr. Odyssey to kindly come forward and felicitate our esteemed resource person, Mr. Imon Mallik. We are really confident enough that today's session will provide us with valuable insights, practical perspectives and inspiring ideas that will greatly benefit all the participants. So, without taking any more of your valuable time, I most respectfully invite Mr. Imon Mallik to deliver his expert lecture. Sir, please.
morning, everybody. Myself, Imon Mallik, as already has been stated. I am working as senior manager in electrical IPH. Presently, I am involved with inside powerhouse electrical maintenance. It covers the areas generator, automatic voltage regulator, and ESP, electrostatic precipitator, which is also related to this topic, that is it reduces environment pollution, and FGD, that is another topic I will cover also, and ash plant. So this is a great opportunity for me to present some ideas related to industry, which would help you to develop or get some knowledge about industrial practices. So this is today's the topic is India's energy odyssey. That is what is India's target in developing renewable energies. Today, as all know, that we are shifting from conventional fossil fuel, that is coal based or gas turbine based power resources, to renewable energy resources. That is, we are shifting towards solar, we are shifting towards wind power, we are shifting towards nuclear power. Why? Because every fossil fuel power resource or energy resource leaves some carbon footprint, that is leaves some pollution effect in the environment. So this is there was an agreement between all the nations, United Nations of all the nations of the world in 2015 in Paris Agreement. Through this, all the nations have agreed to reduce the carbon footprint in the environment. So India is also following this. So today my total presentation will be divided into these topics, that is what is present India's energy scenario. Second is the clean energy, how India is planning to grow the clean energy. Then from fossil fuel to clean energy, when we are shifting, there is what are the challenges? The main challenge is grid. Grid upgradation is very much necessary. That is smart power network or grid. Next, what are the new ideas and tools are implemented for converting the existing grid to smart grid? Then what are the rules or support? This I can skip because there is a time shortage actually. And what are the key milestones we have to achieve within 2030 and 2047? Then what are the DVCs? DVC's current plan and what DVC is doing for decarbonization. What are the DVC's decarbonization initiatives? Then solar power. As already stated that I am involved in commissioning of one rooftop solar power project. I will say something about it also at last. So, as I mentioned that fossil fuel dependence is our present in present scenario, we depend on fossil fuel energy. That is, we are generating energy by burning coal. Energy generation process is very simple. That is, coal is burned in coal is fed crushed. At first, coal is unloaded from red. It is unloaded in a system called track hopper. It is unloaded there. Coal sizes are larger. Those are taken to crusher house and reduced to lower size. From crusher house, these are fed to coal mill. From in coal mill they are reduced to further lower size, that is within 20 mm it is called, that is 75 micron etc. Around this size, and from mill it is fed to boiler. In boiler the fire ball is created. Using this fireball, heat of the fireball, the steam is generated. The steam flow in high pressure to the turbine, and turbine rotates, and connected to the turbine there is generator. Generator generates electricity. This is the basic process. So I will not tell much about it. Now our challenge is that fossil fuel, from fossil fuel we are getting energy, but our GDP is growing. Presently we are in range of 4.2 trillion dollar GDP, but we are going ahead to 10 trillion dollar within 10 years, or 2040 maximum. So when GDP is growing, our power demand, present power demand for it is 548 gigawatt almost. India's total power installed capacity is 548 gigawatt. It will triple. It will go to 15,000 gigawatt. So we have not that much coal resource also. So we have to shift to something that is renewable energy. And India is like all other nations in the world, India is also shifting to renewable energy. So this is a legacy challenge, that is our power demand which will be triple, that could not be fulfilled by our fossil fuel, that is coal resources or coal normal fossil fuel power plants. This is the energy targets. That is as already I came to know that these have been discussed, so I will not tell much about it. That is today 548 is the total installed capacity of India's power energy scenario. And today total solar installed capacity is 157 gigawatt. Within 548, 157 is solar capacity and 57 is wind capacity. So total renewable is almost 210 gigawatt. That is this comes to almost 35 or 40%. But we have to, our target is by 2030, this should be, that is 550, that should be 300 gigawatt. That is, we will generate 50% almost energy. Our installed capacity should be from renewable energy. And by doing what will achieve? Our carbon emission will reduce by 35%. Presently, carbon emission, that is pollution, is carbon emission in the atmosphere is developed by the industries is almost 3 billion ton. And by reducing this by 30%, 35%, this will be reduced by 1 million ton almost. So this is our target. To achieving this target, what are the initiatives taken by Government of India? This is the main initiatives. At first, rooftop solar. Rooftop solar, Government of India has given more thrust. Why? I will cover it in next slide. Next, quality power. Quality power is, what is power quality? Power quality is mainly voltage, current and amplitude. That is, amplitude means waveform. So this power quality, previously what happens? Power quality was not maintained. That in villages, you will get voltage dip in evening, but today the scenario has changed. We are maintaining power quality because at that time there was power shortage. In 2027, energy shortage was almost 16%. But today, as of June 2026, we have power shortage of 0.3%. We have no power shortage. So load shedding is not there. Voltage dip also is not there. and we are maintaining the power quality. Next, EV. EV is another initiative by Government of India. Its target is by 2030, EV, 30% of all the vehicle running in the country should be converted to EV, electric vehicle. And AT&C loss. Loss is a major thing which is hampering the revenue generation of the distribution companies, DISCOMs. Because this loss should be limited to 15%. Presently, the loss is 22%. What is AT&C loss? AT&C loss is actually aggregated technical and commercial loss. Among these, technical is that is distribution network when becomes older, its failure becomes larger. Losses, that is line losses become line losses due to capacitance and inductance of the line. This becomes higher. And C loss, C is commercial loss. Commercial loss is somehow manageable. Why? Commercial loss mainly is due to power theft or meter tampering, etc. So that is an administrative issue that could be controlled by improving awareness among the people or by stringent policy implementation of stringent policies, etc. Next, solar power, rooftop solar. I had mentioned in the previous slide. These are the challenges. First challenge is land acquisition portfolio. This is a burning topic in India. For this, one government also be toppled. So land is our very much burning topic, and land acquisition is first hurdle in power generation or green energy development in India. So for this, government is targeting the household roofs. They are giving some PLI scheme incentives to the households that you install rooftop solar in your house and you generate power, you get some benefit from it. Also, you will be paid for what excess energy you are exporting to the grid. So this scheme is PM Surya Ghar scheme, which is government is targeting to develop the solar power in India. Next, supply chain risk. This is mainly due to when we are developing the renewable energy, we need some raw material also. Raw material resource is not in India's hand because main raw material is silicon, lithium, cobalt. Lithium, cobalt and silicon India import most from Russia, Argentina, Bolivia, Chile and Congo. Congo is the largest cobalt producer in the world. 60% of cobalt is produced from Congo. So this import issue is also there because when you have no control over the raw material, you have no sufficient reserve, then you have to depend on someone. So this is one issue. Then grid integration. We will develop 50% of renewable energy, but how we will evaluate it, how we will send it to the consumers. We need to expand our network, that is transmission network or grid. Previously, one issue was that national grid was not there. National grid, there were some regional grids, that is eastern region grid, western region grid, north grid, northeast grid, south grid. Each grid, their generating station are pushing in the grid and distributed to consumers. But in southern grid, there was always southern and western grid. There was always shortage of power because it has southern region and western region. People's GDP is high. Their purchasing power is more. Their using more appliances, but that much generation was not be available there. So always there was you will hear that load shedding in Delhi. So this has been resolved right now, because the first target of government of India in 2014 was said that we have to build one grid, one nation, and one nation, one grid has been implemented today. And today, that's why today there is no power shortage in India, because there is always something excess power in eastern grid, and they evacuate to other regions. That is DVC exporting power to Punjab, Karnataka, because there is shortage of power. Now, also financial gaps, that is foreign direct investment has been invited, and these gaps almost has been resolved right now. Another thing is cyber security. When we are developing smart grid, we are using some AI, some softwares, etc. So there is always some cyber security risk. So this is a concern, that this is one main challenge, and the other is that is water energy nexus. That is sometimes you will ask that we will stop water going to Bangladesh. This is one kind of nexus. So their hydrant will not work. Like this, everyone can do sabotage to this kind of. China also can do this sabotage to India also. So these are the challenges in RE development. Next, this clean energy are at first from this card you will see that this wind power, is more than solar. But now solar is more than wind. That is, solar development of solar power is more in India than wind power. I will not discuss much in this slide. Next, smart grid. I will discuss something about this. Smart grid is something that previously grid control was done by, now also they are existing, central load dispatch center or regional load dispatch center. What they do, whenever there is stability, actually grid, what is observed, grid voltage, grid frequency. These are main things which are observed. When frequency of the grid increases, suppose there is 10 generating stations connected to the grid, and they are evacuating power to 1 lakh consumers. Whenever one generating station trips, so power injection is reduced, but consumer is consuming power. So what will happen? Frequency will be down. There is always a range, that is 47.5 is the range, 47.5 hertz is the range of tripping of grid. One grid failure also I have observed in 2001 almost probably, 2001. 2009, two times it happens. When total blackout of eastern grid happens, occurs. 31st July, exactly. And at that time, power, that is startup power, came from hydel station. Of DVC startup has startup power we get from Mython hydel. So previously it happens, but now grid is more stable. Because why this is? Because we have done transition from normal grid to smart grid. What is the function of smart grid? Smart grid actually, it do automatic load forecasting for 20 to 48 hours using AI. That is, it has data of consumers, that is load, generation and load of 2 years or 3 years. in a particular grid region, and it has a lookup table, and it is forecasting that today your load will be this, and you have to generate this much. So this load generation forecasting has been done. Also, real-time monitoring is there. We are using nowadays. We are using smart sensors, smart meters. Smart meter is another initiative, that is smart meters, smart sensors, and all the equipment upgradation, that is substation upgradation has been done. So it can monitor the grid voltage and frequency scenario in real time. Previously we monitor in blocks, 15 minutes block. But today, in each second, we do 25 to 100 scans. Okay, so real-time monitoring is possible. So grid unbalance could be avoided much efficiently. So as this real-time monitoring is possible, so demand response is also that is response to demand is also can be done fast. Next, this something which I already have told, that green energy corridor, because we are generating much green energy, but we have to build that infrastructure so that we can evacuate this much of renewable energy to consumers. For this green energy corridor is essential. Now, what real-time monitoring I have mentioned, that is covered in here. WAMS wide area monitoring system. WAMS. This is previously it was controlled by SCADA. In Bokaro, we have that is eastern region. We have first gas insulated substation. GIS, gas insulated substation, was installed in Bokaro. But that was controlled by SCADA, supervisory control and data acquisition. SCADA has been converted or has been migrated to WAMS. What is the difference between two? SCADA scanned one sample in 4 seconds, but today WAMS scans, that is much real time. In 1 second it scans 25 samples. So its action is much faster and its response is much faster. So grid control is much efficiently could be done. Also, previously only magnitude, that is voltage and frequency, voltage only magnitude was monitored. Today magnitude and phase angle, both could be monitored in WAMS. This is something which I already have been told, that is smart instrumentation, and that is AMI, that is artificial intelligence, and smart instrumentation. These are the basic of smart grid implementation, and smart grid is very much necessary for RE integration. Why it is very much necessary, I will tell in next slide. A smart grid knowledge, this has been already I have told this. Power demand forecasting, I already mentioned it. The drone inspection, that is real-time inspection, this has not been implemented in all areas. Some private concerns, which region they are monitoring, they use drone actually. Not all region this has been monitored, but digital twin, this is very vital. Digital twin. What is digital twin? The backbone of smart grid is AI, and digital twin is something like that. We want to convert to all generating station and distribution, that is load dispatch center, all to unmanned. For that, what we have to do? We have to create one digital twin. Digital twin of what? That is 10 years design data and 10 years operation data of a power generating unit would be fed to the AI server or AI creating. That is one already in India is working Pi software that is actually using AI to create digital twin of power generating station. So all data are fed and they usually respond according to load that is schedule and demand for balancing schedule and demand. They respond and observe all the parameters, that is boiler drum pressure, drum level, furnace airflow, furnace that is furnace means boiler pressure, everything has been monitored, and if there is any fluctuation, it see what has in this condition what action was taken in 10 years back or 2 years back, whenever this exact condition come, and that action is taken automatically. So no manpower will be needed if this has been implemented successfully. But presently target for implementing this smart grid digital twin is very much necessary. Some power plants also, NHPC mainly, National Hydroelectric Power Corporation, they are working, Tata Power and Adani Power, they are working on it. But in DVC what happens? DVC units are of BHEL and they use Max DNA software for control room operation. And they have a blocking that they did not share anything to outside agencies. So that at that point, we are also working on digital twin creation, but the work is now postponed due to this. This will be resolved in near future.
No, one question. This digital twin and AI, how much energy they are consuming?
Digital
data center.
Good question. I will say this, that what is the problem of RE integration? RE integration problem is that not conventional power plant are operating previously, are generating full power. That is 500 megawatt is generating 500 megawatt. And they have, these units are mainly analog instrumentation is there. So their response is not so faster. RE response is very faster. Solar, when sun raises, it will generate full power. But thermal power generation station for when suppose there is 10 megawatt requirement. I am giving one example. 10 megawatt is requirement. In the night, thermal power generating station is generating 10 megawatt. When at 8 a.m. Solar irradiation comes, solar power started to be generated, going to the peak. So it is generating say 4 megawatt. So thermal generation have to be reduced by 4 megawatt. Its response is not so fast. There is also one drawback that one thermal power station cannot be operated below 40% of its rated power. That is, it cannot be operated beyond 200 megawatt. It will trip. It cannot be controlled. Yesterday when I was coming, there was a problem that its load become 200 megawatt. Its airflow started fluctuating, and it was almost going to be tripped. But somehow it has been saved by converting, taking the system from auto to manual. Anyhow, there is problem. So this is the main problem of RE integration. So this smart network or smart grid, what will happen? That is, when solar is, it is using RE, AI. So it will predict that it will be 4 megawatt. it will schedule the thermal generation generating station, that is SD it is called, schedule generation has been given in 15 minutes prior. That you have to reduce this by 4 megawatt.
AI is only informing or it is automatically doing it?
It is informing and it is also monitoring the real-time data, and again if it feels that information was not correct, it will correct it also. Okay, everything will be controlled by automatically. It will be unmanned. No manning will be there. So this is a RE integration is renewable energy integration challenge. Main challenge is parallel operation of thermal generating units and renewable energy stations. That is stable operation is today's challenge is stable operation. So we are trying, but somehow in some cases stable operation has not been achieved. Some we have done that. This is for technical minimum. 40% what I have said is for technical minimum. Technical minimum operation in 30% generating thermal generating units is not possible till now. They cannot go to 40%. Even they get down up to 55%. But in that region, it will it will be necessary that they go down to 40%. So they are working on it now. BHL, most of the BHL units, BHL has been given. DVC all station has given contract to BHL for automatic generation control to technical minimum. So their work is going on. In Bokaro, ATC tuning, PID tuning is there. The PID controller is there. Tuning has already been done, but it is under observation. 40 days before tuning has been done, it is under observation. Okay. Now it is already I have mentioned, that is the diagram of the smart grid. The base is AI, and upper circle is generating units and transmission, and distribution actually generating stations and distribution network all are controlled by AI. This has been diagrammatically shown here. Now, what is the threat of smart grid? Smart grid is necessary. RE integration is necessary. But what is the threat? Threat is IT/OT threat. That is cyber security is the threat. Already cyber attack has been 3 or 4 times, I can remember. Already has been done on grid network. First it was cyber attack was in 2020 in Mumbai. That was malware attack. Some malware name I cannot remember, but that was a malware attack. And for this suddenly grid goes to, that is southern grid goes to blackout, and all rails has been stopped, hospitals were blackout, and this is mainly this cyber security is main hazard or main concern of this smart grid integration. Now IT/OT work is for enhancing cyber security work is already going on in power sector. Next, we are integrating to renewable energy, but we already have something in our hand that because our power demand will be triple. I already said we are our fossil fuel capacity or reserve is not so much, so we have to fill the gap by renewable energy. But something we have in our hand, and government already has implemented or have given some policies. So implemented some policies so that this what we have in our hand we have to use or utilize efficiently. First is we have to use energy efficient equipment. that is star leveling is there.
We don't like. There is a backup power backup battery. Battery backup earlier slide.
Acha.
Battery backup. So how much feasible actually this battery is? Life is very low. Battery backup. There is a term. There is a point.
Battery backup will come in later on, but previous slide it was
They
there.
just mentioned that battery backup. So battery is actually very not that efficient. And life is
Because
also-
battery
What type of
efficiency,
battery?
efficiency is not the criteria here. Battery is used for what? That is, we are telling that in for grid stability. Why? Because solar power generate power in daytime. When light goes off, power goes to zero suddenly. So thermal power has to ramp up. It is called ramp up. Ramp up to cover that. Otherwise, what will happen? Grid frequency will be down. So battery, what is the advantage? It will store energy in daytime and deliver in night. So we can control it by there is controller, that is inverter and controller is there in solar panel. We can control that. Previously it was generating for 4 megawatt solar plant, and in night time it becomes 0. So we can control it that throughout the day and night it will generate 2 megawatt. For the battery backup is necessary, and India is already converting. World is also to battery backup system.
So what is battery?
Now, mainly lithium ion or sodium battery, sodium ion, these batteries are used, but presently, or advanced chemical engineering, actually what component they are using, I don't, that has not been disclosed till now. But AEC battery is coming, and government has already announced one PLI scheme, incentive scheme to the AEC battery manufacturers. Okay, battery is there in the next slide, I think. Previously I have not mentioned it. Okay, now what I was telling, that is we have to use much energy efficient equipment. By doing this, we can reduce our power consumption, so that demand will also be reduced. If we triple demand will be reduced to some 40%. If we can control it to 40%, then our generation need will be also reduced. So we can somehow meet the criteria of grid stability. Government also already have implemented the Ujala LED scheme. By LED, what happens? Previously we use one incandescent lamp of 100 watt. Now we use 20 watt lamp. So this much huge set is there. Not only LED light, we are using in BLDC fan. In DVC, all waters has been supplied with BLDC fan. By EESL is one government sponsored. Government has done agreement with EESL, Energy Efficiency Services Limited. This is a private organization, but government has done agreement for supplying to all government agencies the BLDC fan and 5-star rated ACs. LED light also they have supplied to government organizations. So by this LED implementation and BLDC fan or 5-star rating AC implementation, almost annually 48 billion watt-hour, billion kilowatt-hour energy has been saved. So this is huge. Also, star leveling, you all know, that is also this one criteria of energy saving. Next, I will discuss this PAT scheme. This is something new. PAT is one generating station has been given one target. what is the target? This is PAC means perform, achieve and trade. There is an energy exchange, like stock exchange, there is also energy exchange. That is, generating station has been given target. That is our 500 megawatt unit APC target means auxiliary power consumption target. 500 megawatt unit has a target of 5.25% of APC. Their APCs could be within this. If it crosses 5.25%, then it will be penalized. How it will be penalized? Or some organization, if it achieves less than 5.25% APC, then it will be rewarded. How they will be rewarded or it will be penalized? That is, there is a energy exchange. Energy certificates are used. That is, if you achieve less APC, you will be given energy certificate equivalent to the that is certificate price. That is 1200 or 2500 is presently. APC auxiliary power consumption. That is, every generating station have to consume some power for generation. How? Because you have it has to run some equipment. There is a very large equipments like boiler feed pump, which is feeding water to boiler drum at that's 80-meter height, and also CEP condenser, many large equipments for water systems, circulating water pump, auxiliary circulating water pumps, and boiler feed pump, condenser extraction pump. Also fans are there. Induced draft fan for air supply. For combustion air is vital. Fuel air ratio decides how efficiently combustion will take place. So for air supplying, forced draft fan is there, and for sucking the air out through chimney, induced draft fan is there. So these larger equipments consumes almost more than 5% energy. Okay. So 5.25% is the range. So you have to keep your auxiliary power, that is the auxiliary power of the unit, within this range. So if you keep this within range, then you will get some 10 energy certificate. And those industries we cannot achieve this APC target, they have to buy from exchange. That is, this is those who are getting energy certificate, they are rewarded. That is, they can sell to someone or they can sell to exchange in the market and get equivalent money or equivalent money benefit in tax or something like that. So this scheme has been implemented to for rewarding or for punishing the industries which are using more APC or which are successful in keeping APC in range. Next, building code BCEC. It is called Building Energy Code. Building Energy Code is applicable for large buildings. This building also, I think, under ECBC, because if a building, that is a hospital, school, or large housing societies have connected load of 100 kilowatt or more, that has to be ECBC compliant. ECBC compliant means it has to, its auxiliary power should be reduced by 20%. That is what is the normal year. You have to implement some means so that you can reduce it by 20%. So these all means are Government of India target to increase energy efficiency and reduce power consumption, so that we can achieve our goal, that is we can balance our demand and supply, that is generation. This is carbon, that is like energy exchange, there is also carbon exchange. That is carbon credit trading scheme. I will not discuss about this. These are actually Paris Agreement. These are not much necessary. And this international CBAM is international European Union. They are giving some tax on the industries who are selling product to them. for much higher carbon emission. Now, carbon credit trading scheme is that is energy exchange, like energy exchange. Those industries who are emitting more carbon, they will be punished, and those are emitting less carbon, they will be rewarded. How? There is also a carbon credit certificate. So, the industry, we are reducing less carbon, that is, we are polluting less, they will be used on carbon credit certificate. The industries which are polluting more, they have to buy the certificate from the exchange. So they are punished, and those who are emitting less, they are rewarded.
So one question regarding this means someone is selling the carbon to the industry. So recently
They can sell directly, or they can sell to the exchange.
one news that I have heard, that is when Vantara is created, so they are selling the carbon credit there, and in future when the industries who are polluting more, so Vantara will sell them the
Sell them. That is under development. Now it is working. There is domestic emission trading. It is under development. It is government is working on it. Now, I already have been mentioned that for RE development, RE integration, some equipment manufacturing is also necessary, and for this solar PLI scheme, government has sanctioned this much of money in budget, so that the manufacturer of the solar component or wind component, wind turbine component, they get benefited. They get encouraged. They encourage for making the industries. Also, one thing is to mention battery cell production. You already mentioned it. These are also in government's target. Okay, for stability of battery. Wind turbine manufacturing India already have started in exporting the wind turbine components to world. It is one achievement India's. This simple thing already I have mentioned, that is by 100 years of 2047, 100 years of independence, this is our target to go totally renewable energy. Go to total renewable energy, no fossil fuel energy will be there. Okay. 100% clean energy, and by 2030 target renewable energy, now it is 290 gigawatt. Now total RE is 290 gigawatt. On this 157 is solar, 57 is wind power, and hydroelectric is almost 46 to 50, something like that, and nuclear is 2 gigawatt, 6.78 gigawatt nuclear. So almost 290 gigawatt is present RE capacity of India, and we have a target. Right? We have a target to go to 500 gigawatt by 2030, and solar capacity 157 we have already reached. I think this will be reached, or we can go beyond this also, 200. This is the monetary involvement, that is government is already sanctioning this much money per year, and 50% non-fossil fuel by 2030, and 2047 100%. And this already I have mentioned that this much carbon emission by reducing. But whenever we go to 50% RE, then 35% of carbon emission will be reduced, which amounts in total 1 million tons of carbon. 2070, our emission will be zero. These are targets. Already I have mentioned that grid is the foundation, that is smart grid is the foundation for disintegration. To maintain the stability, we have to convert or migrate to smart grid. normal grid will not, by normal grid this will not be possible. Energy landscape, India's energy landscape, that is the present scenario. By 2030 our demand will be 1.5 times, that is 150%, and by 2040 it will be double. So this is due to industrial growth, urbanization, and that is buying capacity of people is rising. So demand is also rising. Now coal, presently 70% of 70 to 80% of total power generation is from coal. So almost 1 lakh employees involved in coal mines, that is coal or related to this generation system, that is from coal production to coal burning. So what will happen to them? Because RE and smart grid is going to be unmanned, and RE is also that much of manpower does not require. But this is a challenge to government, that these coal workers have to be migrated to, or give some how to migrate these workers to new jobs or new RE era. This is a rural electrification. Some schemes government already have implemented this scheme. These are the names. First is Saubhagya scheme. By these schemes was free connection, one smart meter and one LED light to every home who are economically weaker. For economically stable people, this scheme is not there. They can take connection under this scheme, but no benefit will be, they will not get any benefit. Kusum, this is for Kisan Urja Suraksha Evam Uthan Mahayabhijan. The name, its name is this. So this is for farmers. The solar power, they have to they can get incentive from government, so that they can install solar powered pumps for irrigation. This is the main scheme for farmers, and our target is to give power to every people, that is who is staying far in Himalayan region. We have a target to give power to that people also. There is no transmission line, so solar power is the only option is there. Current energy mix is this, that is 49% coal, solar is second, 18% almost, and hydro is third, hydel 11%, and wind 10%, wind power, wind turbines, and nuclear 2%, other renewables like biomass, etc. They are 10%. And India is the third largest energy user in the world, and fourth in RE, renewable energy generation. Now hydropower basic already in previous session I think has been discussed, as I want to learn. That is, the basic concept is same. That is, water is kept at some height reservoir, and that potential energy, that height is potential energy. Through this potential, water falls from height, and its potential energy converted to kinetic energy of turbine, and connected to this turbine or generator is there, we generate electricity. Now, Himalayan regions, that is hilly regions, we can by making a reservoir at height, only in hilly region is possible. So mainly these hydro stations are in Himalayan regions or hilly regions. There is also one option, that is pump storage. What is that? That is also one option for giving grid stability. What is that? Like battery storage, pump storage is also. That is, hydel power is dependent on environment, nature. That is, in rainy season we can generate. When there is not sufficient water, we cannot generate. So pump storage is another option for keeping constant generation. What happens in daytime? Solar generation is more, so we will keep our hydropower plant at shutdown, and we will pump up the water to a reservoir at higher level. But generation will not continue in this time, daytime. When at night solar power goes out, then we will start generation. So we can integrate this pump storage to solar for giving constant power to grid. So this is another thing, that is pump storage for grid balancing. And already in West Bengal there is pump storage projects in Tista and Purulia. Purulia pump storage is one of the oldest, that is from 2007. It is working under, it is under WBACTCL, Purulia pump storage. Also in Purulia, NHPC is also working for building two pump storage projects in Purulia Bagmundi. That thing already I have mentioned, that is pump storage. There is water is kept in this reservoir, and it falls down, and turbine is here, and electricity is generated. Nuclear capacity already I have mentioned, 6.78. 22 nuclear reactor total in India is working. And we have a target by 2031 is 7.5 gigawatt. Main nuclear plant disadvantage is disposal, nuclear waste disposal. It is green energy. Nuclear power is green energy. No carbon is produced. But nuclear waste disposal is issue, really issue. Another issue is nuclear. That is uranium. Uranium is mainly used for nuclear power generation. The reserve of nuclear uranium in India. India has less, mainly it exports that uranium which is used for nuclear power. That is not natural, not normal. It is some refined or high quality uranium is required. That uranium India mainly export from Russia, Canada, etc. Import from Russia or Canada. So they depend on other countries. So India is what India is working on to mitigate this issue. They are working on thorium strategy. What is thorium? Thorium is also one radioactive material, but it has no natural radioactivity. Uranium is uranium in reactor, the nuclear reactor. Uranium is U-233, its atomic number. It is bombarded with neutron. It is converted to plutonium and releases energy. This plutonium is in second step used with thorium, and this thorium and plutonium combine to form the uranium. Actually, uranium is formed using thorium. So this uranium again used in normal process in which nuclear reactor uranium in which it operates. So thorium is used to use the plutonium which was produced from uranium in first stage to reproduce the uranium. What is the advantage of this? This has the advantage, that is thorium. India has almost 25% of world reserve of thorium. So if this is under development stage, one prototype reactor, that is, it is called fast breeder reactor, FBR. One prototype FBR has been made and under development stage. If it becomes successful, then in nuclear energy, India can reach its target is 100 gigawatt. Its target, it can reach. Otherwise, it is a little difficult. In nuclear reactor, what happens? Already mentioned, that is thorium, uranium is bombarded with neutron and it releases energy and produces plutonium. This energy is used, huge energy is energy. This is a chain reaction. This energy is used to heat the water. That is actually one in reactor rod. This reaction happens, and this rod is cooled by one water, cooling water. This cooling water is again came in contact with DM water, which produces steam, and by using this steam, turbine and is rotated and generation is done. So these all reactions happen in normal nuclear reactor.
It cannot produce electricity, always producing heat.
It produces heat, and this heat is used.
Which is very bad. This is not efficiency, not good.
Efficiency not good, and there is a risk also, hazard is there. Anyway, this green energy, so we are concentrating in it. Okay. Nuclear process, which I already have been said, this is called the neutron split releasing immense energy. This is called fission reaction. Okay. Next. Wind energy. Wind energy. India have huge potential. India has the potential of generating almost 70 gigawatt of wind energy. As per survey, it has almost 7,600 coastal area. In coastal area, if all we can utilize all coastal area, then 70 gigawatt energy could be produced. But now India's wind power capacity is that is 70 gigawatt almost could be produced. But wind power is now 57 gigawatt installed capacity. There is a wind total main basic principle is same. That is, we are using the that is wind turbine is there, and it is rotated by wind, and connected to this turbine there is a generator, so we can generate the electricity. But what is this also has some drawback, that is stability issue. It cannot produce throughout the day same power. The same, there is always some this issue with renewable energy. Okay. And this thing is green hydrogen. Green hydrogen already I think has been discussed in previous some sessions. Green hydrogen actually is produced by electrolysis. This is not new technology. In major thermal power station we have a hydrogen plant, generating plant. Why hydrogen is there in thermal power station? Because its generator, which is the largest or vital equipment of the generating station, is cooled by hydrogen. Hydrogen cooling efficiency is very higher, and to reduce the volume of the generator, hydrogen is used as coolant. Previously it was not used. At that time large generators were there. So we have a hydrogen plant, and green hydrogen was produced there 20 years back. This is not new process. Green hydrogen is actually electrolysis of water. That is, what is broken by sparking into oxygen and hydrogen. Both we can use, but oxygen generally left in the air because some oxygen preservation process is very complicated and needs larger investment. So green hydrogen India, this is actually will be used as fuel for larger applications like aircraft. Also there is one hydrogen train has been successfully trial run from Jind to Sonpot in Rajasthan for almost I think 1200 kilometers. It has successfully trial run has been done. For this 3000 liter diesel has been saved. So this is a great initiative for saving fuel future for fulfilling our need. Now, I already have been covered the wind power and nuclear power, pump storage, hydel, and now I come to solar. Solar is the main our focus. That is government's focus also is solar, because India has huge solar probability. Solar, India is in the equatorial region. Solar irradiance is very high, and almost 300 sunny days on an average is there. Sunny days 300 on an average, mainly in western, southern, and central region. There 300 solar days is there. That is solar sunrises. So India has a target to be almost what target I already have shown that by 2030, 200 gigawatt of solar power India has target, and in 2014 what was India's solar installation? Could you tell? In 2014 India's solar power was 2.6 gigawatt, and today India's solar power is 157 gigawatt. In 12 years, almost 150, more than 150 gigawatt solar installation has been already implemented, already done, and few are in pipeline, but already installation will be completed within this year.
The household or industry?
There you have, good question. Household rooftop. There 157 gigawatt in 157 gigawatt if we give breakup, land that is land mounted solar power plant is 118 gigawatt more, and rooftop is 28 gigawatt. Okay, so land mounted actually India is exploring its land which are barren lands, mainly in Rajasthan. Rajasthan is the highest producer of solar power as of today. It has installed capacity of almost 42 gigawatt in deserts. And second is which state? Gujarat. It has installed capacity of almost 32 gigawatt. So two plants I have mentioned here. One is Bhadla. It is of Rajasthan. 2.25 gigawatt, highest capacity in Asian region. This is the highest, largest capacity solar plant, Bhadla. And Pavagada is this is basically Pavagada in Gujarat. This is this is actually combined. That is, wind power is also there and solar power is also there. This is combined power plant, not only solar plant. This scheme already I have mentioned, PM Surya Ghar. This is actually rooftop solar.
Task is too much, right? It is a task.
One thing, I will show one video how to mitigate this issue. Because solar panel needs main maintenance is there, cleaning. How to mitigate this issue? They are using robot.
Use water before.
No, water is not used there. They are using robot for just like vacuum cleaner. They are using robot. Automatic cleaning is there. I will show one video. This robotic cleaning process is shown there. Very innovative. That is, no water is there, all maintenance are automatic, and this is the largest. Next, solar technology. This will later on. Kitna time? 12:30. I have to complete. No? Okay. Solar technology. This main two types of crystalline solar panels are used, monocrystalline and polycrystalline. I will discuss this thing in my last slide. So now I am skipping this, and this is the first generation solar panels. This is the first and second, monocrystalline first, poly second, and thin film. This is somehow this is costlier and not being used, under development actually, not being used in very much large scale. And this is a new thing. Floating solar. Floating solar actually DVC, Damodar Corporation, has mainly exploring its reservoirs for developing installing solar panels. So it is mainly working on floating solar and rooftop solar, because land is always there. DVC has land. DVC's land is not less, but all are occupied. It has huge land. All are occupied and they will not live. So this DVC is exploring it, floating solar. Same thing, that is solar panel installed on the reservoir. That is, water surface is used and some floater is used on which the solar panels are installed. Now this, what is this? Concentrated solar power.
The floating solar cannot use in ocean. Sea.
Ocean can also be used, but there is one issue. What is the issue? To transmit the power to the consumers or substations. One issue is there, that is only cable can be used, and those cables will be very robust because it has to some tidal force, etc. Those cable cost is very high. India is not working on it. I will not say this. India already have been working on it. The cable transmission for not for this on solar panel on sea, for not for that, for transmitting power to Sri Lanka. They are running cable inside the sea, and it has almost capacity of 500 megawatt. That is a large project, but some issues, this hurdle is there, because it becomes some initial cost or return on investment will be much larger period. So because costing is higher. Okay, concentrated solar power. Concentrated solar power is what is it? Solar energy. Solar energy has solar sun rays has two kind of energy. One is that is UV rays, which is used in solar panels, and one is thermal energy. That thermal energy is used in concentrated solar power. Here what happens, one reservoir is there and mirrors are used. That is in school days we do one experiment. There is using mirror we used to burn the papers. Same thing is there, mirrors are used, and that solar thermal energy has been concentrated to that reservoir.
Mirror lens.
Mirror lens. That converts to that reservoir, and in this reservoir water is heated and to form the steam, and but rest is same. This steam is used to rotate turbine and for generation of electricity. This already has been mentioned that PM Surya Ghar 1 crore aim is 1 crore already. What is the scheme?
They are giving subsidy.
Subsidy, what is the range of subsidy?
18,000 per kilowatt and maximum 78,000.
Actually, the scheme is like that. That is from 0 to 2 kilowatt, you will get 60% subsidy. That is your installation cost. If it is 2 lakh, you will get that is 1,20,000 subsidy. And if 2 to 3 kilowatt installed capacity, your solar capacity is 2 to 3 kilowatt, then you will get 40% subsidy. Subsidy will be reduced. And above 3 kilowatt, 78 is the fixed, not in percentage. It is 78 is the slab. Above that, you will get rebate for 300 units. Initial 300 units. More than that, if your generation is more than 300 units, that is you are exporting to grid, then you will get money for that also. So this is basically incentive scheme to encourage people to install rooftop solar in their roof, so that total installation RE target could be achieved using the land, roofs of the people. Good initiative is very good,
But we are not getting the benefit of it because they are imposing so much of condition and restrictions.
Restrictions are there.
You have to pay
Then peak hour, off peak hour, those are there also. And charges are
actually that subsidy is utilized to get whatever subsidy you get, that you have to pay back.
Payback period is more than, I think, 5 to 8 years actually. This is actually basically prosumer model, producer and consumer model. You are producing as well as you are consuming. Same thing, like all solar plant, it has some component. It is using solar irradiance, that is UV ray is used. Also, it has one inverter, because solar power is produced. What kind of power it is? It is DC power, direct current power. So, and what our appliances are mostly AC. So we have to convert to DC to AC. So inverter is used. Already, if you install the plant, they will install the inverter also. Net metering, what you are saying, that is what you are consuming, what is your excess, that has been calculated, and for that you will be paid. Battery storage, someone can opt for this also. That is throughout the day they can control their usage, and throughout the day and night they can use their solar power generation. Now, battery storage. Battery storage is mainly, I have already discussed, is for grid stability. That is, already I mentioned that you can regulate your generation and regulate your delivery or consumption. Next generation, that is lithium ion. Presently it is lithium ion. Advanced chemical cells are being under development. India is starting some private organization, I think, what name I cannot remember. They already have built one plant, they are working on it, advanced, and the government also have given some PLI scheme, incentive scheme for AEC battery producers, so that AEC battery production could be encouraged. This is already I have mentioned that this loss discoms that is disadvantage or hurdles of discoms is this loss. It was in 2014 it was 22%. Now it has been reduced to 17%, and target is within 15%. In the fourth year or fifth slide, I already have shown it. AT&C loss. Transmission infrastructure, I already have mentioned it, that is a green energy corridor for evacuating the renewable energy to the consumers. EV, already I have mentioned, that is our target by 2030, our EV, that is total vehicle, 30% of total vehicle should be electric vehicle. And there is one new thing, V2G. What is V2G? Vehicle to grid. That is almost 12,000 EV charging stations has been installed, and target is 1 lakh. In NH, within like petrol pumps, within 25 kilometers there will be EV charging station. This is our target actually. And V2G is that during this vehicle charging, you will connect to this charger, and it is connected. This solar panel is connected to grid. So through this charger, when your vehicle is connected, excess that is, it is getting charged to its battery, but excess power it is there, that will be fed to grid also. And there will be metering system, obviously. These are the targets. I did not mention this. Already I have covered this, Paris Agreement, etc. So our our target already I have mentioned that Saubhagya scheme and PM Kusum scheme I already mentioned, that is 2.86 crore household should be already has been electrified, and another 30 billion is our target, and we have a target to give power to remotest people staying in remotest location. Energy to all is our target. Next. Time.
12:15.
Damodar Valley Corporation, I have to tell in brief. Its present RE initiatives of Damodar Valley Corporation. Its present installed capacity is this much, 6715 megawatt, and target is this much by 2031. This much of monetary involvement is there, and 27% is the RE target. Present these plants are there operating. Media Thermal Power Station is the highest capacity plant, 2.34 gigawatt, and hydropower is Maithon, Panchet and Tilaiya. 3 hydel plants are there, 147 megawatt. Solar installed capacity presently is 28 megawatt. These are mainly some floating and mainly 10 megawatt solar, rooftop solar. This is the expansion plan, that is RTPS 1.32 gigawatt, that is 1320 megawatt. New plants are coming, and DTPS is also there. 800 megawatt unit is coming in DTPS. DPR already has been done. Project report. CTPS work has been started for this.
How many plants are there under DVC?
Under DVC, Media, Raghunathpur, Andal. DTPS was previously, now it has been decommissioned. New unit is coming here. And in Jharkhand, Kodarma, Bokaro, Chandrapura, these are. Maithon, there is Hydel, Panchet Hydel, Tilaiya Hydel, and also some mines are there, captive mines are there in Chhattisgarh. Chhattisgarh is the state which has largest coal reserve in India, Chhattisgarh, and second is Jharkhand.
Mindset of coal production.
Many big plants of NDVC are in Chhattisgarh, and what new plants they are developing in Chhattisgarh, because
These are not, sir,
DVC has mine in Chhattisgarh.
DVC mines also there.
In Chhattisgarh, and one wind power DVC has installed. It was target was in June 2026, but it has been delayed in Durgapur, Gujarat. 50 megawatt. This is 50 megawatt, and 147 hydel, and 2025 solar installation was 28. Now it is 462. Among these, floating solar plant in Maithan, in Konar dam. Konar is also a big dam in Jharkhand. Konar dam, Maithan floating solar is 234 megawatt, and Konar 220 megawatt. These are adding to 28. So come 462 present. And another 1900 solar capacity addition is targeted by 2032. These are some plants which are coming, actually become very less size. So 755 megawatt largest solar will be made by DVC in Maithan. Okay, Maithan floating solar, and some land mounted is also there in Kodarma and Mejia, 8 megawatt. Also, actually as the time is passing, so I am keeping this much. This is also one measure it already present in thermal power station, electrostatic precipitation. This is a pollution control measure. So I only say basic of this, less I will skip it. This is the steam generator boiler. This is ESP, electrostatic precipitator. What happens? This flue gas, this is the flue gas part, is going to chimney. So this is carrying lots of dust material. This is for mainly dust removal or ash particle removal. So to separate this from flue gas, we have installed this ESP. Mainly the air, that is flue gas, is ionized. There is two plates. One is collecting, one is emitting. Emitting plate is negatively charged. That is, it is emitting electrons. And those electrons, as accumulated as particles collect those electrons, become charged, and the collecting electrode is grounded. That is positive. You can assume that positive in respect of negative. So these as particles, when becomes charged in contact with emitting electrode, they go to the collecting electrode and stick to those plate, collecting electrode plate, and some hammers are there. They used to wrap, that is hammer the plate, and those are collected in the hoppers installed in and under this collecting electrode. So this is the main principle. These are typical data. It need not be mentioned here. How much collecting and emitting electrodes the hoppers is there.
How many plates are there?
This is actually in Bokaro 500 megawatt. There are 80 fields. 4 passes, 20 fields in each pass. Total 80 fields, and total collecting electrode is this much. And total emitting electrode is this much. Emitting electrode is more because it is sectionalized. It is actually spring structure. So it is almost 8 to 9 times than collecting electrode.
So for 500
This
megawatt.
is a typical data for 500 megawatt.
How many precipitors are making? Yes. If I generate 500 megawatt, we have to place the chimney for that. So how many precipitors?
And the precipitator is only one. It has 4 passes and its capacity is n minus 1. That is 80 fields. You can keep off one field in each field, each pass. 80 actually 80 fields collecting and emitting. One collecting and emitting set is called one field. Each field is charged by one transformer, HV rectifier transformer. Okay, I will show in later slide.
Is 80 transformers are there?
80 transformers are there on the top. These are rectifier transformers. Like this 80 transformer in series, each pass you will see.
Each rating of the transformer?
Rating is 75 kilovolt and volt ampere rating is 100 something like that. It's typical, it can vary. And its voltage rating is very high, 70, and one special thing is that 75 kilovolt, 75 to 85 kilovolt DC, and this is one special thing is that insulating oil. Insulating oil normally in transformer mineral oils are used. These transformer use silicon oil, and whose rate is almost double than mineral oil.
Silicon oil?
Silicon oil because purity breakdown voltage it has normal space is less, so its size is less, core to body gap is less, so it breakdown voltage has to be maintained. Also silicon oil is not hygroscopic. Other mineral oil is much hygroscopic than silicon oil. So there is always some risk because we are generating high voltage. So silicon oils are anything. Anyway, this is I have mentioned that 70 kV, it is 75 is its rating. 70 kV is produced generally, normal operation 75 we keeping some margin, we go to 70 kV. Also its controller, that is voltage can be controlled. 70 kV is generated, but there is controller is connected to it so that we can regulate the voltage to the field depending upon requirement, that is load condition. Load when load is less, gas particle is less, will reduce the voltage, save the energy. For controlling this backform controller is there. Through this sparking rate would be controlled also. And wrapping, this is backform controller is for wrapping mechanism. That is hammering. That is in first field within half an hour hammering has been done. In last field, where gas collection is very late, hammering has been done in 2 hours. That is frequency after 2 hours, one hammering has been done. And this is done in auto. These are some pictures, photographs. This transformer is a normal distribution transformer. This is not rectifier transformer. This is used for what? This is used for some heaters are there in hoppers. Some wrapping mechanism motors are there for those, and illumination system. For this system, these distribution transformers are there. This is typical data, the maximum spark rate which setting we can done in backbone controller, 5 sparks per second. Now, flue gas desulfurization. This also type.
20.
Sir, is it?
Ah.
Yes.
না স্যার এখনো 10-15 মিনিট হয়ে 5 মিনিট আছে 7 মিনিট
ঠিক আছে। So flue gas desulfurization is another pollution control measure. What is this? We are installing one plant after ESP and between chimney. This was actually Government of India initiative. Now this system has been discontinued. This is mainly to eliminate the sulfur disposal in the flue gas. That is SO2. SO2 disposal will be eliminated by using this is the block diagram. Flue gas going to, there is limestone is used. Limestone, one absorber tank is there. Flue gas is limestone is sprayed by this pump, sprayed from the top, and flue gas is going to chimney, passing this tank, that is passing through the limestone. And what happens? This is the absorber tank inside. The spray nozzles are there. These are spray nozzles. And when limestone come in contact of the flue gas sulfur, this reaction happens. That is CaSO4. This is called gypsum. This is the byproduct. So we are removing this byproduct is sold in the market. Gypsum is used in cement industry. So we are removing the sulfur from the flue gas as well as we are earning revenue from it. So this is called flue gas desulfurization plant. This in Bokaro this has been installed. Media also they have installed. But now government has discontinued this thing because Indian coal sulfur is not so much in high range. So it is not necessary combination. Sulfur is 40%.
India.
Sulfur 35 to 40. And previously its limit was less, SO2 limit. Now government also increases its limit because that not in harmful range. It has increased from 250 to almost 400 something ppm. So main basic thing is this FGD. So in thermal power station pollution lowering measures are ESP and FGD. And now RE, that is solar rooftop solar project I have commissioned in Bokaro Thermal Power Station. I will say something within 5 minutes. Okay. This is the total sunlight, sun irradiation which comes in the earth, and within this we can consume this much of. Others are reflected. Tera, whatever. So this implies what? That is 6 hours sunlight could power the world. 6 hours sunlight which comes to the earth, our energy can fulfill our energy need if we can utilize. We cannot utilize, but if we can utilize. And total 20 days solar power which comes to the earth is equivalent to total fossil fuel which is under world's reserve. Total capacity of fossil fuel is sufficient for 20 days solar irradiation. This is a typical fusion reaction power which power is generated and which power comes, I already mentioned, in per year. This point also I mentioned that solar PV cell work on. This is the solar radiation. What kind of wavelengths are there? What kind of energies are there in solar irradiation? That is divided in three wavelengths, three ranges. One is ultraviolet. Solar PV cell operates on this ultraviolet range. And visible light. This is for our need, and infrared, that solar thermal CST. These operate on infrared. Now, India irradiation capacity is very much high because it's a geothermal location. Now, already I have mentioned monocrystalline is the first generation. It has the highest efficiency now, at present. And second generation is amorphous silicon. These are CIGS, CD, cadmium, tellurium, and amorphous silicon. These compounds are used. Here silicon is used. These compounds, amorphous silicon and CIGS, CDT, these are used in generation of solar cells or panels. Third generation is multi-layer, gallium arsenide. This is commercial development has started but not been used. It has some cost factor is there, and efficiency is more, 47%. This efficiency is 21%. This its efficiency is almost within 20%, and its efficiency is 47%. That is solar cells efficiency is very less actually. We can use only 20 to 47%, which is under development of its radiation. Now these are the typical efficiency data. Now how solar panels are made? Solar panels are made by melting pure silicon, not any impurities should be there, pure silicon in high temperature, that is 14 to 16,000 degrees centigrade. Now 2000 degrees centigrade also used in polycrystalline, making polycrystalline solar panels. So
in India or import from
silicon available, but silicon, there is silicon triangle. Silicon triangle is mainly Russia, Canada. They are largest producer. India is also silicon available. But pure silicon, you have to refine it at first. That raw silicon should not be used in making these panels. It has to be refined at first. Pure silicon has to be extracted from it. No impurities should not be there. Otherwise, the panel will.
Silicon is not freely available in nature. It is available in silica.
Silica. It is available in
It is
silica.
not silica. Making sand from sand.
That is raw, and it has to be refined. Now, it has been melted in high temperature, and it becomes liquid. Then one crystal is dipped in this liquid and form one cylinder. This cylinder is called silicon ingot.
So one thing, which one is mostly used? Monocrystalline crystalline or polycrystalline?
Crystalline is mostly used, and we are in DVC we are using monocrystalline because it at present market it has the highest efficiency, 21%, 22%. Monocrystalline PERC. It is cells name monocrystalline PERC. Okay. Passivated emitter and receiver cell PERC. So ingots are produced. These ingots are carted into pieces which are called wafers. These wafers are used to form the panels. Okay, solar panels. So this is the main process. This is the that is liquid and crystal dipped, and cylinder ingots are produced, and mono and polycrystalline. What is the difference between these two? One thing, these you can, if you see solar cells, these structures are seen. These are called fingers. These are small cells, and they are connected to this bus bar, one bus bar in parallel. That is, they are multiplying current, and this one cell have voltage capacity of almost 0.5 volt, 0.6 volt. So these different cells are connected in series to increase the voltage, and these fingers are connected in parallel to increase the current range. What is the difference between mono and polycrystalline? Visual difference. What is the visual difference?
Which is more efficient?
Color, this color can be changed. Its efficiency is less because this structure. If you see one cell,
So many
if you see this kind of structure, this is monocrystal. And if you see this sharp edges, this is polycrystal. And in this edge, loss is more. History is. This is a structure of solar cell. This backing material. These are I already have shown that those cells are placed here, and this is one panel. Different cells are connected series and parallel. One panel is made. On the upper layer there is glass, and this is EVA, ethylene vinyl acetate. One coating is there, and this is cells, and this is actually strengthening material. This is called TEDLA or TPT. This is also polymer compound, TEDLA or TPT in back side.
What is the purpose of the EVA?
EVA is actually this this cell, some photon are collected, rays are get reflected, it gets upper, and it again sent to solar cell, so that maximum energy could be utilized. Okay, so it is actually reflecting back to cells again. And this lower material is for actually strengthening. This is the solar, how it is actually PN junction diode. PN junction diode, I have no time to explain. N type silicon is doped with when doped with phosphorus, N type silicon is produced. When doped with boron, P type silicon is produced. Okay, PN junction diode is formed, and by getting the photon energy of sun, it is free electrons are produced. Those are creating the current to the load. Okay, these are some typical data of the solar panels which are used in Bokaro and Durgapur. This is a typical block diagram. This is the panel, and this is converter. That is DC to AC. DC power is generated, DC to AC is converted, and then some load dispatch, that is panel is there, that is controller, and loads are connected to this. This is basically block diagram, same thing. And you can if you want to transmit, you can boost up, that is step up the voltage using transformer also. These are some panels which has been installed in Bokaro, rooftop panels.
So one solar cell can generate how much work?
How much cell you have to connect in series, that depends. That is for generating 240 volts, you have to, the one panel you want kilowatt capacity or kilowatt capacity. Kilowatt capacity is 545 to 600, 650, 700, different are there.
But one cell can generate how much?
0.5 volt, 0.5 to 0.6. This is the inverter actually. This is inverter, and the cells are placed in this angle for getting most radiation. That is, sun is moving like this. So if you make angle, so radiation you will get more.
Sir, the backside of the solar panel also contribute some
Backside of solar. Backside of solar panel there is one terminal, that is positive and negative power get out through this.
Is it also producing some power?
No, it is only connect center. Okay. Some videos are there, but some time so I am concluding here. I think if you have any question, you can ask.
Any question from participants? Okay. Now,
Thank you.
one thing I just want to say that I don't know how our resource person got some news of the previous sessions. Now I just want to reveal that where from it has been leaked. But before that, I just want to ask one question to everybody. I don't know how many of you have a chance or opportunity to watch a one-day match where Virat Kohli is playing and Anushka Sharma is just sitting over there to watch the match. But it has we only have an opportunity of similar kind. So, any guess who is the Virat Kohli and who is Anushka Sharma, who is sitting over here? Okay, it is Shri Mallik ma'am, who is a faculty member of our department, that is Computer Science and Technology, and Virat Kohli is Imon sir. So thank you very much. Thank you once again, Imon sir, Imon sir. It was a wonderful session. We will looking forward for such kind of session for our students also, so that they will be benefited, and as well as some technical session for faculty members also. Thank you very much. Our next session will be continued with this one. There will be no break. If you just want to take a break of 2 minutes, you can take, but it's a 2-minute break only. Just a 2-minute break because